Today, I have the pleasure of speaking with Will Weathers, National Accounts Manager at Finish Thompson, about how to select the right pump solution to ensure safe and efficient operations when handling challenging fluids across a variety of industries. So, Will, you've identified three key factors to consider when choosing a quality pump solution: reliability of supply chain, versatility and applicability, and environmental and safety benefits. Can you walk us through how each one impacts decision making?
Sure. Let's start with supply chain. Simply, supply chain, you want to get the product when you need it, have it available. In that, it's critical to be sure that supply is quick, reliable. You may need complete pumps, you may need parts. You want to be sure that you can get those to repair your pumps when you need it as well. So, when you're dealing with a pump supplier, you want to make sure that they can manage all aspects of their supply. Be sure they can build the product in a timely fashion, make sure they're not restrained on materials, getting materials in. As an example, Finish Thompson, I'll just bring that up. So we design, we manufacture, and we assemble our pumps in-house. So it gives us control of all the critical components that are needed. And especially in mag drives, you have critical components because we're dealing with chemicals, right? So trying to make the most reliable chemical pump we can. It's important to be sure that everything's done correctly. You have control over it. And, with our processes, our vertical integration process, we actually control each part of that process along the way. So we can react quickly, get the product to the customer, make changes to the product quickly as the customer needs it. Looking at our process as an example, we control all aspects of the process. So for instance, we do our own injection molding. We do our own rotomolding. We do our own machining. We even have our own tool shop where we can build new molds for new products or modify molds if we need to. So you can see there we control all parts of that process. Another important factor of the supply chain, of course, is distribution. You want to be sure whatever supplier you pick in a pump manufacturer has a robust supply chain as far as their distribution network is concerned. When you're dealing with aggressive chemicals, you want that distribution network to be knowledgeable. So you want knowledgeable personnel that you can talk to be sure you're selecting the right product. If you have critical processes in your plant, you want to be sure you can get those products. You want that distributor network to be sure they have product on the shelf for you, have it in your local area. Distribution networks are very, very important. With Finish Thompson, we have a worldwide distribution network. We also have regional managers throughout the world, and those regional managers are there to support the distributors, support the end users. Supply chain is very important there. So as far as versatility and applicability, well, it's very important when you're choosing a pump manufacturer. Most plants require pumps and they're transferring fluids a lot of different ways out of a lot of different types of containers. Each one of these different types of pumps for different areas of the plant, they may all be pumping aggressive fluids or aggressive chemicals. So as an example, in a plant, you could have pumps that unload bulk chemical from a rail car. Maybe they're unloading bulk chemical from a truck. Maybe you're unloading bulk chemical straight from a supply tank that's already been delivered. Sometimes that unloading happens out of the bottom of that truck or rail car. Sometimes it happens out of the top. Each of these ways may require a different type of pump. You then need to transfer that bulk chemical wherever it may be. You may need to transfer it into a smaller day tank in the plant. You may need to actually pump it directly into your process. In some cases, you even have plants that deal with chemicals in small containers. They may be pumping out of drums or totes. So as you can see, there's a lot of different ways that customers use pumps throughout. In chemical manufacturing or chemical distribution plant, not only are you unloading all those chemicals, but then you're mixing and loading chemicals over to a truck or to a rail car or to a drum or a tote. So lots of different ways they can be transferred. In many cases, you have waste chemical in your process. So after these chemicals are used, they may be put into a waste sump. Now you've got to get that waste chemical over to water treatment. And then when it's in water treatment, you have chemicals you're transferring there. So lots and lots of different applications. So you want to be sure that the pump supplier you pick has the versatility in the pumps that you need when you're searching. Finish Thompson as an example, I'll bring that up again. I've often referred to us as a one-stop shop for chemical transfer. I've mentioned that to customers before because our products are very diverse. We have non-metallic pumps. We have stainless steel pumps. Most everything we do is compatible with chemicals, but we pump everything from DI water to acids to caustics, what we specialize in. And we have a very diverse range of products for doing that. As an example, we have ANSI dimensional mag drive pumps with all non-metallic wetted components. Those go up to 1,400 gallons a minute. We even have a pump small enough to hold in your hand. So a very wide range of pumps. We have sub-in suction pumps. We have self-priming pumps. We have non-metallic mag drive pumps for top or bottom unloading. When you look at our self-priming pump to get it out of the top, any way you need to get it out. I didn't even mention drum pumps. We have drum pumps. So if you need to get it out of a 55-gallon drum or a 275-gallon tote, we have centrifugal pumps you can put down in there, or we have air-operated diaphragm pumps that can do that as well if you wanted to do that. So any number of things. So versatility, diversification of product for applications, that's what we can do. So very diverse product range. The last thing you mentioned was environmental and safety. Obviously, this is very important for plants. Every user of pumps is concerned about being sure they're handling chemicals the right way to protect the environment. So when you're pumping chemicals, you want to minimize leaks. That's the biggest thing. Sealless pumps are a great way to do that. Your typical pump would be a mechanical sealed pump. That's what a lot of people use. Unfortunately, seals, just in the nature of that, mechanical seals have a potential to leak. They're dynamic seals. They wear. If they get scratches on those faces or those faces get damaged in some way, that seal is going to leak. When you're dealing with aggressive and hazardous chemicals, that can be a problem. So using sealless technology, which is a lot of what we supply, can help prevent these leaks and give the user environmentally safe and reliable choice for pumps that can handle, all the hazardous chemicals they have.
Now, Finish Thompson constructs its pumps from materials like polypropylene, PVDF, ETFE, and stainless steel. Can you elaborate on the properties of these materials and why they are particularly suitable for handling corrosive fluids?
Sure. The materials you just detailed, most of those are non-metallic or some sort of type of plastic, right? With the exception of stainless steel, of course. Those are types of plastic. And each one of those materials has different compatibilities to handle different types of fluids. They also have different costs. So you have to address what's your compatibility at your lowest cost, really, for each fluid that you're pumping. So when you're evaluating that, you have to evaluate the material based on the compatibility. And as an example, polypropylene. Polypropylene is the least costly of those plastic materials that you mentioned, but it's also compatible with caustics and it's compatible with a lot of acids, but it's not compatible with all acids. So what do you do with those acids when polypropylene is not the right choice? Well, that's where we move to PVDF. So PVDF is compatible with more aggressive acids, but it's not compatible with caustic. So polypropylene with caustic, some acids, PVDF with acids, but not caustic. So you can see why we already have a couple of different materials. PVDF pumps we manufacture, they also handle a higher temperature range than polypropylene. So temperature may be a reason that you select PVDF. The last one you mentioned there was ETFE. ETFE, while not compatible with every material at every temperature, probably the most compatible of those materials with acids and caustics and higher temperature ranges. So it can handle a lot more versatile chemicals and at much higher temperatures than those other ones. What's the trade-off there? Well, ETFE is even more expensive. So when you're looking at that, polypropylene being the least, PVDF next, and then ETFE is probably the more expensive one of the three. But the reason for having multiple materials is to give the user the most effective, but also the most compatible product they can have. So comparing costs, comparing compatibility, and picking the right product. That's the key.
Now, magnetic drive technology is a key feature in Finish Thompson's pumps. Could you explain how this technology works and its advantages over traditional mechanical seal pumps in terms of performance and safety?
Mechanical seal pumps, which we mentioned earlier, I think I mentioned they had dynamic seals that can leak. So your typical mechanical sealed pump, I'm going to give you a little visual here. Your typical mechanical sealed pump has an impeller. That impeller is attached to a shaft. That shaft goes out the back of the pump. So that impeller is physically connected to the shaft, goes out of the back of the pump. Then that shaft of the pump is physically connected to the motor shaft. That way, when the motor starts to spin, it starts to spin that pump shaft. The motor shaft spins the pump shaft, which spins the impeller and allows the pump to do its job. Well, you can imagine if you've got a wetted area where that pump impeller is and that shaft is going out of the back of the pump, you've got to have a hole in the back of that pump. Well, if you've got a hole in the back of that pump to keep it from leaking, you've got to seal it up somehow. And that's where mechanical seals come into play. So you've got two seal faces, think of two donuts, if you will, and a shaft going through the middle. And one of those seal faces or donuts is connected to the shaft, and the other one is stationary. So as the pump begins to rotate, or the motor begins to rotate, which rotates the pump shaft, those two seal faces are running against each other. The running together of those two seal faces, as liquid tries to run out of the pump, when you're pressurizing that pump housing, liquid's trying to squeeze out of that hole I talked about. But those seal faces are so flat running together, the friction of those two running together is evaporating any fluid before it comes out of the pump. So that's how mechanical seals work. And again, it's great. They do a great job. Key there, though, is, as I mentioned earlier, if those seal faces wear out, which they're going to, typical life is somewhere between 1.5 years, 2 years on a mechanical seal if it's run properly. So if those seal faces wear out, that seal's going to leak. If those seal faces get scratched, it's going to leak. If those seal faces get damaged in some other way, that pump is going to leak. That's the trouble, if you will, when you're pumping aggressive or hazardous chemicals and using mechanical seal pumps. Anytime I have this type of application, even though we also offer some sealed pumps, anytime I have this type of application, I try and move the user to a mag drive pump, which is what you asked about. And here, mag drive pump is a sealless technology. It uses a liquid barrier. Sometimes people call it a containment shell. And that containment shell is sealed by a static O-ring. So when you put that pump housing and that barrier or containment shell together, there's an O-ring that goes in there that seals it up. But that O-ring's static. It's not moving. It's not going to wear out. So as long as you choose the right materials in the pump housing and the containment shell, you choose the right materials in an O-ring, theoretically that pump is completely sealed up and containing the fluid. You're not going to have to worry about it leaking in that respect. Now you have an impeller inside. How do I turn that with a mag drive? Well, that impeller inside a mag drive pump is attached to a magnet assembly. We call it the inner drive. So that whole inner drive impeller assembly is inside that pump. Okay. So imagine magnets attached to that impeller. Then on the outside, we have what we call an outer drive. That outer drive is a series of magnets that's attached to the motor shaft. So it's another assembly attached to the motor shaft. Now, when you put those two pieces together, there's magnetic attraction between the outer drive on the outside of that containment shell and the inner drive that's attached to the impeller on the inside of that pump. As that motor turns on and begins to spin, the magnetic attraction between the outer drive and the inner drive through that containment shell, through that plastic, is what's rotating that impeller. Okay. So you have no physical connection between the motor shaft and the pump shaft. There is a shaft inside the mag drive pump, but it's stationary. Some people call it a spindle. It's just sitting still. And that impeller and inner drive assembly has a bushing that rides on that, and it rotates around that shaft as opposed to the shaft spinning. Again, that outer drive is turning that inner drive, and that's what's rotating the impeller. Think of a magnet on top of the table and a magnet underneath the table. You move one magnet underneath the table and the one on the top moves. It's kind of the similar thing. That magnetic attraction is happening through that containment shell. So that's how a mag drive works. And you can see, because everything's contained within that housing with a static O-ring seal, this type of sealless pump gives the user a reliable and safe way to pump hazardous chemicals. And I keep talking about chemicals and hazardous chemicals, but really it's any fluid that you don't want a mechanical seal. We can pump water as well. So any place you don't want a mechanical seal, mag drive fits the bill.
Now, self-priming capabilities are important in certain pump models. Can you describe the principle behind self-priming pumps and explain scenarios where this feature is particularly crucial in industrial applications?
Yeah, I can do that. Let's talk about the maybe applications first and then kind of talk about how the pump works. But I mentioned earlier that you have top unloading of rail cars, you have top unloading of trucks. In some cases, you might be unloading out of the top of a supply tank, and you want to get that out. You also have those waste sumps I talked about, where waste chemicals down in a sump, and you need to lift that out as well. When you're doing that, you can do that with what's called a standard in-suction centrifugal. But if you use an in-suction centrifugal, you have to make sure that pump remains flooded. Okay? You have to make sure the fluid stays in that pump and stays in that line. And there's ways to do that. However, a lot of cases when I have these types of applications, I'm recommending a self-priming pump for the application, because that self-priming pump can evacuate air out of the line. With a self-priming pump, it's capable of building a vacuum right at the suction to basically evacuate any air from the suction line and allowing the pump to do its job. There are a lot of different types of pumps that are self-priming, in particular air-operated diaphragm pumps as an example, or can also be self-priming. There's gear pumps. There's other things that are all self-priming pumps. But I assume what you're referring to here is our SP mag drive pump, which is where we're talking about transferring chemicals and having that ability. So when you're talking about chemicals and unloading chemicals from trucks, rail cars, you want to be sure it's reliable. You want to be sure it's safe, right? Especially trying to get that out of trucks and out of rail cars. So even when you're doing sumps that are holding fluids, you need to be able to get them out of the sump and transfer them safely around the plant. Because you have air in that supply line that's supplying the pump, or maybe the loading arm that's loading out of the top of a rail car or a truck, you have air in that line, you need to get that air out. And that's what the self-priming pump does for you. When you're talking about centrifugal pumps and those being self-priming, on a centrifugal pump, when fluid hits the impeller, hits the eye of the impeller, and that impeller is spinning and pressurizing the liquid as it goes out of the impeller, the eye of that impeller is creating a low pressure area with that fluid in it. So when it creates that low pressure area, it creates a vacuum at the suction of the pump. And that's what allows it to bring the fluid to the pump by creating that low pressure area. So, that's why within suction pumps, they're also called flooded suction pumps, because those pumps have to be flooded because they have to have liquid. If they don't have liquid, they can't build a vacuum. So with our SP series mag drive pump, we have a large housing on the front, and it's true with most all self-primers. There are trash self-primers and different things, but with ours, with a chemical self-priming pump, we have a large housing. Inside, there's an internal volute, and that volute is what allows the pump to build pressure inside the pump. But that large housing holds fluid for us. So when you first install the pump, you fill that housing full of fluid. Once that housing is full of fluid and you turn it on, we now have fluid there for that impeller to create that low pressure area we're talking about. So when it's spinning, it's creating a low pressure area, which is creating a vacuum at the suction of the pump. When it creates a vacuum at the suction of the pump, the liquid is then pushed over to the pump, but it's also pushing the air out of the line. So the pump itself can handle the mixed media. It brings in the air bubbles out of the top of the pump, out of the discharge. That's what the discharge is. It bubbles out of the top. The liquid falls back in that chamber and is recirculated. So basically that pump is sitting there recirculating fluid, letting the air bubble out as it's coming to the pump. Eventually, all the air gets out of the suction line. The liquid hits the suction of the pump. And now that pump pumps just like any other in-suction pump that's out there, and does exactly what it's supposed to do. The key there is once you suck some air, guess what? It's going to evacuate it again. If you're looking at this in a sump environment and you turn the pump off and the liquid runs back into the sump, if you don't have a foot valve on it and runs back into the sump, that pump is going to reprime and prime itself again. So that's why it's beneficial for customers. Customers like self-priming pumps for these applications because it can handle and evacuate air out of the line when you have those types of applications. So our pumps, they're sealess. Our SP pump, it's a sealess mag drive, as I mentioned. We can make them out of polypropylene or we can make them out of PVDF. So it can handle a full range of chemicals, full range of temperatures, and it makes a nice fit when you have those top unloading or sump applications.
Thank you, Will, for sharing your insights on how to select the best pump solutions for corrosive and hazardous liquids. For more information, visit finishthompson.com.